Video, we'll see the integration of EPAX and the TAU performance system on the ARM64 platform. In the past few years, we have witnessed a rapid evolution in the ARM architectural designs. These design changes are targeted to address the requirements of large-scale HPC applications and include many core designs, enhanced memory hierarchy to reduce data movement-related stalls, design of systems with large and customizable vector units to support varying degree of data parallelism through scalable vector extensions or SVE. While the architectural designs are making ARM more applicable to HPC codes, applications must also be refactored and optimized to take advantage of these systems. Robust performance analysis tools provide guidance in this refactoring and optimization process by providing information about application hotspots, for example, function level and loop level profiles, and specific performance measurements that describe how well the codes are utilizing key architectural elements such as the vector units and many cores. For the performance analysis to be widely used by developers in their efforts to mitigate code porting and optimization, it is important that the tools be easy to use. For example, no application relinking or recompilation should be needed to deploy the tools. The tools must work at scale on production systems and applications. And most important of all, the tools should support applications written in C, C++, and Fortran. The technique of binary instrumentation enables development of tools with these features. Binary instrumentation, BI, refers to the process of adding specialized performance engineering code or snippets directly into the compiled executable or binary. BI toolkits provide the underlying base component for performance analysis tools such as TAU Commander that can enable the instrumentation of the binary to collect detailed information about the application behavior. As such, BI Toolkit will foster a rich ecosystem of performance analysis tools for the ARMv8 architecture. TAU Commander provides an underlying base component that can instrument the executable binary, inserting code which collects detailed information about application behavior. As such, BI toolkits can foster an ecosystem of performance analysis tools for the ARMv8 architecture. To that end, EP Analytics has prototyped a BI toolkit for the ARM architecture under the auspices of the DOE SBIR Phase 1 award. The toolkit is slated to be released as open source software. Some of the key distinguishing features of EPAX include support for C, C++, and Fortran, support for MPI applications. That is, performance analysis can be done at per rank level, and introduction of optimizations that reduce overhead of the BI technique. In order to provide HPC users with a performance analysis tool that is already widely adopted, EP Analytics has partnered with Paratools Inc. Paratools develops TAU Commander. With this partnership and integration of EPAX within TAU, developers can now utilize features of EPAX from within the TAU Commander tool. So let's see a demo of how this works. I have logged into an ARMv8 system and it's running Ubuntu. Let me just rebuild the HPGMG benchmark. I'll look at the finite volume case and let me rewrite this binary. And add tau hooks at the routine boundary in all of these functions. Now, as we can see, we have two binaries. To execute this, I will launch 8 MPI ranks with the HPGMG fv.t timer binary. But instead of launching it in this manner, I will use tau exec to instrument the MPI level and also introduce event-based sampling at the statement level. Now this benchmark is running and it will generate performance data that I will pack using the paraprof tool. And let me say hpgmg underscore fv.ppk. And this file can now be viewed in paraprof. But before I launch paraprof, I will just copy this file and bring it over to my local machine and launch hpgmg fv.ppk. So here I can see the performance data for each of the 8 ranks. If I right click, I can see the thread statistics table that will show me the data collected for all the functions. And these function names are obtained by instrumentation of the binary using EPAX. I can also go down further and see at the statement level the call. And I can see the exact line where this function is being invoked and how much time it took with these names instrumented using EPAX. So we can see that this is the smooth function and see how much time it took on every rank. You can also launch the 3D visualizer in TAU and see the data on a per rank basis. These are MPI ranks, these are the functions, and here's the time that these functions took. And we can see for each thread how much time a given function took. Zoom in and zoom out and rotate this. So we can use TAU with EPAX to evaluate the performance of this application.